You'd think cranking up the heat would make water vanish faster, right? More heat, more evaporation. That's just common sense. But nature doesn't care about your common sense. This is the Leidenfrost Effect. And it breaks everything you think you know about heat transfer. Watch these droplets. They're not boiling, they're not sizzling away. They're dancing, skittering across that surface like tiny hovercrafts on a mission. Drop water on a pan at 300 degrees, gone instantly. Violent boil off. But crank that pan to 500 degrees, the water just vibes. So what's going on? How does more heat lead to less evaporation? The answer is hiding in a layer you can't even see. Here's the cross-section. See that tiny gap? That sliver of space between the droplet and the scorching metal? That's a vapor cushion, a self-generating force field of steam. The moment the droplet's bottom layer touches that extreme heat, it flash evaporates into gas. But instead of escaping, those gas molecules get trapped. They bounce between the liquid above and the metal below like tiny springs, creating pressure that levitates the entire droplet. And here's the kicker, that vapor layer, it's a terrible conductor of heat. It's basically an insulating blanket made of steam. So the hotter the surface gets, the thicker that vapor cushion becomes. And the thicker the cushion, the longer the droplet survives. More heat, less evaporation. Let me show you what that looks like on a graph. Now, this isn't just some lab curiosity. Engineers have been exploiting this effect for decades. And the stakes? They're massive. And if you think that's extreme, imagine dealing with Leidenfrost dynamics when you're trying to cool a rocket engine burning at 6,000 degrees. SpaceX and every rocket company on Earth has to think about this. In a Raptor engine, fuel flows through tiny channels in the nozzle wall to absorb heat from the combustion chamber. But if the wall gets too hot and a Leidenfrost vapor film forms in those channels, the coolant stops absorbing heat efficiently. The wall temperature spikes, and you get what engineers politely call a rapid unscheduled disassembly. An explosion. The Leidenfrost effect isn't just cool physics, it's the difference between a successful launch and a fireball. But here's where it gets really wild. Scientists aren't just trying to avoid the Leidenfrost effect anymore. They're weaponizing it. Check this out. Scientists built a maze out of superheated metal with tiny sawtooth ridges on the surface. When a Leidenfrost droplet hits those ridges, the vapor underneath escapes asymmetrically, pushing the droplet forward like a jet engine. No motors, no pumps, no friction, just a water droplet racing through a maze on a cushion of its own steam. It's essentially a self-propelling hovercraft at the millimeter scale. Researchers are now asking, what if you could build an entire computer out of this? Frictionless droplets carrying chemical information through heated channels. No moving parts, no electronics, just thermodynamics doing computation. Microfluidic logic gates powered by the Leidenfrost effect. Single drop of water, hovering above a surface hot enough to melt solder, protected by nothing but a whisper of its own vapor. Sometimes the universe's most beautiful tricks hide in the spaces between things, in the gaps we don't think to look. I'm Scientific Nipsey. Thank you for learning with me today. Stay curious, and next time you see water dance on a hot pan, remember, you're watching physics break its own rules.